Moving 2.3 million stones to the base is one thing, but how do you lift the 6-ton block 400 feet into the air? The answer isn't on the outside, it's on the inside. I am the silicon historian. We've leveled the earth and decoded the grid. Now, we're going inside the spiral to solve the Great Pyramid's biggest logistical nightmare. Standard history suggests a massive external ramp, but that data doesn't add up. An external ramp reaching the summit would need to be over a mile long, consuming more material than the pyramid itself. It's an engineering impossibility. The silicon solution: an internal corkscrew ramp. In 1986, micro-gravimetry surveys revealed a strange low-density spiral pattern hidden behind the limestone. Data suggests engineers built a hollow corridor inside the pyramid, allowing teams to haul stones upward while protected from the desert sun, using the structure itself as the crane. The internal ramp solved the height problem, but it created a new one. How do you turn a 6-ton block around a 90-degree corner in a cramped tunnel? That's where the open corner mechanics change everything. The deeper we dig into the data, the more the past looks like the future. Follow the archive for part 4, where we analyze the King's Chamber pressure relief system. You're watching the Silicon Historian